So how can you tell when you're at one point of the one part of the vanishing point and you're moving to another point, another part? How can you like exactly predict that when you how can you exactly predict what angles you have to draw them in? And I think that comes down to how far away from the vanishing point you are. You can exactly predict how you can exactly predict the exact angle. I don't know why I've never seen a video like this, but I had to just figure this out on my own. And yeah, I figured out this knowledge, so I wanted to share it with everyone else. So when you're looking at, like, let's say for simplicity, it's one exact part here. Let's say this is the exact part that you want to draw the grid from one part to another. And when you're doing this, you have to not look at it like you're moving this way from the grid, like this part to another. You have to look at it like you're growing from like one circle, and like the circle is like growing. Well, yeah, I'm just gonna for simplicity, I'm just going to be really talking about one vanishing point. When you're growing from one vanishing point to another, like you have to look at it like you're growing like a huge circle, because a circle from one angle will always be the same, even if it's like a billion kilometers long. The angle from zero, come on, focus. Sorry about that. The angle from 0 to 45, let's say this is 45, will pretty much always be equal. Like if you like take the points like here, if you take this angle and you draw like a horizontal line, you'll always have 45 degrees no matter how infinitely long it gets. And yeah, that means the circle right here, this is the tiny circle you can see here. If you're moving this way, then the circle's radius, that means from one point to another, that means it's growing a lot. And when you're growing a radius, that means the angle from 0 to 45, let's say, is also growing, relative to how big you're growing the circle. And yeah, let's say for simplicity, the circle, like let's say you're viewing the circle from I don't know, let's say like 3 circles here, and you're viewing like the 45 degree angle, and as you can see right here, 45 degrees, like 3 circles from here, is going to be halved and halved. Like from here to here, from here to here is exactly the same as from here to here. So that means half of 45 is going to be halved, is going to be halved, is going to be halved. You have to kind of look at it like ratios, because I can't really use exact measurements. Let's say this is from here to here, like from here to here is like 1 centimeter. From here to here will also be 1 centimeter. From here to here, if there's another circle, it'll be 1 centimeter. So it has to be like halved. If this is 45, then this has to be like 22.5. And if this is, you kind of get it over and over again, half, when you're growing this way. And yeah, I think I kind of tried to figure it out a little bit over and over again. So yeah, this is kind of the big kind of theory that I have. And I think I kind of said the same thing. As you're growing as you're moving this way, you're growing the radius. And if you're growing the radius, like you're kind of moving this way, then yeah, the whole radius will be, if you're moving this way, then, and you're growing the radius, that means you're looking at it from a steeper and steeper kind of angle. If the radius is like counted by 5, like think of it as like these kind of like mini eggs, like mini circles. you're moving this way, you're going steeper, steeper, steeper. That means the 45-degree angle, which is half, will be halved and halved and halved, and that'll be the next kind of middle angle, like this. And if, like, let's say the radius will be multiplied by 5, that means the 45-degree angle from here or something like that will be, or any part here, because you have to be the same thing. Let's say it has to be the same thing. Let's say it's like 60 degrees over here or something like that, or it's like, I don't know, like 80 degrees around here or something like that. And if you're moving this way, that means the 80 degrees has to be divided by how much exactly you're moving by, the radius. And this might sound like weird and complicated. I'll show you an exact real example. Here, I will show you exactly from a perspective grid. As you can see, I did the calculation before. Here you go, perspective grid. All right. So we're gonna start with the vanishing point right here. So look, check this out. Check this out. If we start from here, like this is our like relative kind of example of angle. It doesn't really matter. This part will be exactly, we're gonna predict exactly what angle. We're gonna predict exactly what angle this part, oops. I'm gonna shrink this a little bit to be a little more simpler. We're gonna predict exactly what angle this exact part of my computer will be. Here, I'll show you. If we have these, if we have the angle, the angle number here, measurement, I'm sorry. That looks like it's about, I can't really see too well. Okay, can you see it? It looks like it's about 50 degrees, right? 50 degrees. Okay, how far do you want this to be? How far do you want it to be like moved? Do you want it to be, I don't know, like 5 circles moved? Like, let's say like you want it to be, let's say crazy example, like 8. You want it to be like multiplied by 8. Can you focus? All right, thank you. Let's say, like for this, for example, how many kind of circles do you want it to be moved by? What is the radius you want it to be like expanded by? Let's say I want it to be expanded by like 7. That's a weird number. So 50. So we're gonna take this example. For instance, this is 50. You guys saw this? We'll measure this again. 50 degrees. Can you see it? 50 degrees. Okay, this is exactly the same everywhere. I don't really care to check it there. 50 degrees. Can you see that? 50 degrees. It's 50 degrees pretty much everywhere on this line. 50 degrees. Okay, so we're gonna measure this, multiply this by 5, and we're gonna predict exactly what angle this part of my computer screen will be. So if we can predict how much it's going to be moving left by. Let's say we want it to be expanded by 5, radius of 5. Okay, so we're gonna have 5 times. We're gonna be moving this 5 times, moving this angle 5 times. 1, 2, 3, come on, 3, 4, 5. There we go. Okay, so it's not exactly, there's no line here. I'll just put it in normal mode. Normal angles, there we go. There, as you can see, can you guys see this? There's a line there. So we'll measure this, and first we're going to predict what it is. Did I say 5? Yeah, I said 5. Okay, so we said 5, so we're going to divide 50 into 50 degrees into 5. So that means if we have one vanishing point here and we're going by 5, 1, 2, 3, 4, 5, this is the angle that, and if we have every single angle over and over again by 5, we'll have 10 degrees exactly at that point. So this is 10 degrees, I'm going to predict. And as you guys can see, if we measure this line about, we have, can I see this? About 10 degrees. Actually, oops, I should probably measure here. 10 degrees, can you see that? That's exactly the point that we had, and that is 10 degrees.